Hello, my name is Laia Turmo Vidal, and I'm presenting the work that we did with Hugh Zhu and Riego-Delgado on BodyLights, open-ended augmented feedback to support training towards a correct exercise execution. Most movement teaching and learning practices, like sports or fitness training, require a correct movement execution to make training effective and not harmful. The apparition of body sensing technologies has led to a plethora of designs that focus on supporting trainees in achieving a correct movement technique. But the current overarching design approach in these solutions focuses on automatizing correction and instruction processes, giving technology the assessing role. These solutions often present technical limitations in assessing movement execution, providing feedback on singled-out technique parameters, for instance balance, or course indicators that disregard precision and accuracy. And they usually are able to provide feedback only for a limited set of exercises, one or two. In addition, the assumption behind this design approach is that what constitutes a correct technique can be specified and modeled under simplifying benchmarks. But in reality, what entails a correct technique is contextual and situated, depending on individual trainees, their skills, and their abilities. In this paper, we explored a complementary design approach in which technology offers open-ended augmented feedback. These are open representations of body data, presented to users in a non-assessing and non-interpretive way. Previous works designing for physical training have proven that open-ended feedback is useful to support a general reflection on performance or instructions. So we wondered if this approach would also be useful to support a very normative practice, and if this type of feedback could help training towards a correct exercise execution. To explore this question, we turned to strength training as a practice, and engaged in a research through design project following an activity, soma-based and practice-based design approach. We involved a personal trainer and expert trainees in the co-creation and made use of embodied design methods. We designed and studied the inclusion of BodyLights in 18 strength training exercises. Design. BodyLights is a 3D printed wearable optomechanical device. It is inspired by previous works using visualizations to support physical training. BodyLights is placed in key body parts or in the equipment, as you can see in the pictures, and projects a laser cross in the environment that moves as the wearer moves. We designed the inclusion of BodyLights in 18 different strength training exercises. We did so together with a certified personal trainer and 3 experienced trainees over the course of 4 co-design workshops of around 3 hours each. We focused on key movement technique aspects and common errors that BodyLights could visualize for each exercise. Our design considerations for each exercise were the course location of BodyLights in the body or in the equipment, the projection direction, and the interplay of the projection with environment and spatial marks. The personal trainer would use a dynamic interplay between the BodyLights projection and these spatial references to provide instructions and feedback. The final set of exercises included 7 full-body exercises consisting of planks and 5 variations of planks and deadlifts, 4 lower body exercises, including squats, leg bridges, and lunges, 4 upper body exercises, including dumbbell raises and press, barbell press, and barbell row, and 2 core exercises, crunches and Swiss ball abs. This is an example of how our design works. This is a simple plank, where a key technique aspect is to have a proper back posture, with the knees, the hips, and the shoulders aligned in a straight line, as you can see in the first picture. The personal trainer positions BodyLights in the trainee's chest and adjusts them so that when the trainee is in the correct position, the cross projection is placed across their palms in between their hands, as you can also see in the first picture. If the trainee during the exercise deviates from the correct posture by bending or extending the back, as in the other 2 pictures, the projection will move from in between the hands, either further in the mat or back in the mat or to one side or another. This is something that the trainee can see, but that the personal trainer can also use to give further cues or corrections or feedback. Study. We ran an evaluation study with 15 participants, 7 women and 8 men. 7 of them were beginners, 5 intermediate, and 3 advanced. Our study consisted of participating 3 times over 2 weeks in a tailored and balanced workout, consisting of 4 to 6 of our exercises and lasting 40 minutes approximately. We recorded a training session and the post-work interviews with the trainees and the personal trainer, and did a video analysis and thematic analysis on the data. Results. Our results show that both the personal trainer and the trainees found the inclusion of BodyLights useful to support execution, error identification, and to provide tailored instructions and feedback. It helped in execution because trainees were able to visualize different technique parameters at the same time, such as movement trajectory. For instance, here, doing a Swiss ball ups, the projected cross travels up the wall as the trainee goes back, tracing a straight line. Another one is posture, as in the planks, the example that I presented before. The third one is movement pace. For instance, while doing squats, several trainees became aware of how their pace going down was faster than going up, because they could see it now visualized in the projections of BodyLights. The trainees used this pace visualization to pace their movement, and the personal trainer to give them cues about speed. And finally, BodyLights could also visualize muscle engagement. For instance, in this barbell bend row, if trainees engage too much their upper back muscles when rowing, instead of the arms, the projection of the BodyLights that they have in the chest will significantly move away from the marker in the floor, as you can see in the second picture. BodyLights supported error identification because they offered a precise visualization of all those parameters. As one trainee mentioned, "For me, it's like a mirror. It's a way in which I can see my body. It's reflecting my movements, how tired I am, how straight I am, how fast I move." Trainees could compare their visualization to the benchmark given by the personal trainer, which they used to identify errors. As the personal trainer mentioned, "I don't need to repeat the instruction every time. I just confide in BodyLights to take care of it. I don't need to repeat the basics. With the light, they know, and some can correct it by themselves." BodyLights also supported the personal trainer in providing tailored instructions and feedback. The personal trainer could adapt the design to suit different trainees, for instance by repositioning BodyLights in their body, adjusting the projection angle, and tailoring spatial references. Also, the personal trainer could use the visualizations to adapt the instructions and feedback, for instance to draw attention to different parameters for different trainees at different skill levels, or adjust what the correct technique was for each individual. You can read more details about the results in the paper, but I want to end this presentation discussing some key design takeaways and the contribution of our work. In the paper, we present 4 key design takeaways that underpin the usefulness of BodyLights. Again, I refer you to the paper for a more detailed and nuanced discussion on them. First, intimate correspondence. The augmented feedback was perceived as an extension of the body, and trainees could easily relate to it and understand it. Second, the fact that BodyLights augmented several important technique parameters at the same time. Third, that it offered a shared frame of reference between the personal trainer and the trainees, allowing both of them to refer and orient to the visualizations and use those to communicate with each other. Finally, that it offered trainees with an external focus of attention and feedback, which in sports science has been widely acknowledged to support working towards a correct technique. In terms of contribution, beyond the usefulness of training with BodyLights, in the paper we discuss what an open-ended feedback offered in comparison to prevailing design approaches to support training towards a correct exercise execution. First, it offered versatility in the parameters augmented, given that BodyLights do not sense nor recognize parameters per se, but rather offer a visualization that the personal trainer endows with meaning. Second, versatility in exercise is supported, from 1 or 2 that are commonly supported to 18 in our design. And finally, adaptability to individual trainees at different skill levels, catering to their anatomical particularities, their needs, and their abilities. Our work extends current work on technology design for strength training, and more generally, we hope it might inspire future design work for movement teaching and learning domains, where correctness of execution is crucial. And with this, I finish my presentation. I encourage you all to read the paper for more nuanced details on the project, on the insights, and the design takeaways. But thank you very much for being here today. And also special thanks to Annika Vern and Dimitris Babalikis for their comments and their help. I will actually be taking questions now over Zoom. Thanks.